In this video, I'd like to go over my Crossfade Router plugin. A Crossfade Router is meant to replace the router component while crossfading on the output, so fading between the two, while also providing a mute for each output. So internally, for an 8x8 mono crossfader, it would have an internal router that is 8 by 16, so the input count is number of inputs. The output count is the number of inputs times 2. And then there is one crossfader per output with the input A wired to its corresponding input. So output 2 would be output 2, and input B on that crossfader would be its output plus n being the number of inputs. So that would go over to 10. Then there's a embedded gain component just used for mute. It uses the default 0 for gain, so it will not change the level. This looks very simple when it's in mono, but imagine scaling this up to multi-channel or stereo or even bigger, say 24. It could get pretty out of hand in a design, while a plugin can very dynamically change to, say, only 4 inputs and 8 outputs, or 8 inputs and only 4 outputs, or if we needed to support stereo or multi-channel. It is very flexible. On the UI of the control Crossfade Router, we have just the simple, it's meant to almost exactly mimic the router component using the same control name. So if you already have a script that is going to control a router, that script will also change a Crossfade Router. There are select buttons, and there are also the input selects. So I could select 2, I could select 6, same as I can on a standard router. And you could also scale that up and down. There's a mute here, just like there is an output mute here. We have to use gain components as opposed to using the output mute on the router. Just simply that it is post crossfading. Any of the internal routing, I make sure that it's muted after that. And then it also gives me a capability, if I wanted to add gain control on the output, I could add that in the future without changing my components and just changing a little bit of code. The Crossfade Router also has controls for the crossfaders, so whether it's constant gain, constant power, and a crossfade time. And it is set to the default of a standard crossfader. For example, we could set it to a 3-second constant gain, and that would affect all the internal crossfaders in this plugin. Okay, so now we looked at the plugin. Let's take a quick tour of the code. We'll work from top to bottom, so a lot of the definition of a plugin down into the runtime. At the top, I just have some basic information: plugin name, author, versioning, ID, and description. In Designer, the plugin info name is what shows up in your schematic elements. So if I disconnect here, that is where we see here, Crossfade Router. Also, when we go to install it, that is where we would see the version and the description. The ID has to be unique across all plugins and assets on your computer, including assets from Q-SYS library or legacy asset manager. Then you also have, I have a quick table of colors that I use in my layouts. This is copy and pasted from a bunch of plugins that I write. Get color defines the color of the plugin itself. I use the same color as a router because it's meant to replace it. Okay, then you have get pretty name. We're just printing the name and the version. That is what shows up here on the plugin front if a user doesn't change it. Then I have my pages, control, and settings. The reserved function get pages is what passes that into Designer to say, hey, there are these 2 pages to show. Then we have our properties. We have an input count, 2 to 128, default of 8, much like a default router in Designer. Same thing with the output count. Then we have our type. We have mono, stereo, multi-channel. This is the same thing as a standard router, as well as count, which is hidden unless it is multi-channel. The same thing like a router. The only thing that you may see here that is different is I added descriptions. This is used by a script I have to generate help documentation. So we'll see that in the help doc later. This is a good practice right now. Just add some more context to your code without using comments and actually assigning it a key value pair so it could be used by other tooling later. Then we have our get pins. This is what defines these input pins and output pins on the plugin. So we have a couple an if tree here for mono, stereo, and multi-channel. So you just generate those pins. For example, if it's just mono, we're just going to go through our input count, create input pins that are named input space, then the number, direction of input, same thing with the output. If it is set to stereo, we want to do the same thing. Per input, we want input 1 left, input 1 right. Same thing with outputs. Output 1 left, output 1 right. And we just iterate through that count. And lastly, same thing, multi-channel. So input 1 channel, whatever channel it is. So we have a nested for loop here. So for every input, for the amount of count, create the pin. Same thing for the output. For each output, output count, do the thing. And then it returns that back to Designer, and that's how we get our pins. Then we just have one rectify property. So rectify property is a reserved function that lets you hide and show properties depending on other properties. So we want to hide the count property if it is not multi-channel. Then we have our embedded components. We just define a couple things here, a table to put them all in, what our type is, mono, stereo, multi-channel, and then a type index. We're going to pass that type index further down the line. Then we need to input our router. We are going to call it router. It is of type router with output. And then we have our inputs, outputs. So our output count times 2, like I said before. Our multi-channel type, which we are passing that index 1, 2, or 3, mono, stereo, multi-channel, and then the count value. Then we have to define our crossfaders. So for every output, we need a crossfader, and we are just indexing them X fader 1 through number of outputs. Same thing, multi-channel type, we are passing along that index 1, 2, or 3, mono, stereo, multi-channel, and then the count, which is only used if it is multi-channel, but we still pass it along to the component. And then we define our gains. So we're indexing the same as crossfader, gain 1, 2, 3, so on and so forth. Same thing, multi-type index, count value. and then we return our components. So this will result in us having a single router, a crossfader per output, and a gain per output. Then we have our wiring, a table to add our definitions to before we return it at the end. And we have the same thing like we were defining our pins. We're going to do if type is mono, stereo, or multi-channel. And what we're doing in each of these definitions is saying we have a wiring definition that's going to wire from this pin to this pin. So using mono as an example here, we want to go from our input pins directly to the router input of the same index. So input 1 on the plugin wires to input 1 on the router. Then for each of our outputs, we want to wire the gain output to the actual output of the plugin. So we're using this pin here to actually wire to the output. Then we want to wire from our crossfade router output to the gain input. So working backwards, crossfade output to gain input. Then we want to go from our two different router outputs. So the first output is going to go directly to input A. And then our output, which is the index plus the n, which is our output count, goes to input B. So that does all the wiring automatically for us, and we don't have to worry about wiring up hundreds of wires in Designer if you use a lot of these crossfade routers, or if you're doing stereo or multi-channel. You see for stereo there is a lot more wires to go, and multi-channel is a little bit simpler since you don't have left and right. You could just go channel X, input or output X to channel Y down the line, and then we return our wiring, and that internally wires up the whole plugin for us from the code. Lastly, we're going to define our controls. So we're going to define the select knob. So that is these controls right here are actually knob controls that are shown as text. This makes sure that it only takes integers and it has a defined minimum and maximum. So minimum is always going to be 1, and then max is going to be our input count, which the smallest could be 2 and the greatest could be 128. We're going to say it has a default value of 1. We are going to say pin style of both. That means for control pins. So if I look at output 1 select, there is a input control pin that lets you set the output selection via an input or an output. So say you want this to trigger other stuff, another router or some other code, you could have this control trigger other stuff. And user pin true means the user needs to selectively show it. If user pin was false, this pin would always show. And then I have a description once again for propagating to my help documentation, and also gives me a little description while reading the code. If someone else other than me needed to read this code, they can see what I intend this control to do. Then we have our mute. We have, which is just a basic mute toggle button. We have a fading LED indicator, so we need a control type indicator and then indicator type of LED. For example, this one is only an output. Typically indicators, you will only have an output. You don't want indicators to be controlled outside of the plugin. I'll show how that looks here. Fading, output 1 fading is just an output pin, no input pin. Okay. Then we have our output input select buttons. So these are the buttons here. So these are all these buttons here are the controls we're defining here. So for every input, define an output. Because X right now is our output number, Y would be our input number, and they're all toggles. Then we have two global controls. So we have our crossfade time and our crossfade type. These are copying min and maxes from the crossfade router itself. Okay, so that's all our controls. Now let's get into our layout. The way I like to do my layout is I'll have a pair of tables, layout and graphics. I have my current page, and I have a couple variables here for storing sizes or such. Then I like to work an XY coordinate system. So on the first routing page, I'm going to insert a graphic. So this graphic is going to be this output box here, and it is going to be dynamically sized by the amount of outputs and inputs that we have around, plus a set spacing. It says output, we're aligning the text, so on and so forth. And then within a row, what I'll do is Y will increase. Then there's our label. Or as I go down the page, I'm going to increment Y. So Y equals 28 plus the label size. Then we are going to put our label. In this case, it is mute, which is to the left. Then we are going to move over. Then we are going to increment through our mute controls, so on and so forth. So I'll do this for the entire layout where I'm just incrementing X and Y and occasionally resetting them. And then we have our second page, which just has a whole lot of very static layout. Since I'm not incrementing through dynamic controls, I don't need to worry about using my full XY coordinate system. I could be very explicit. So that is all of the design time logic. So here's the runtime of the code. It's actually quite simple. So we just have definitions for our input count and output count. Then we have tables for our crossfaders and gains just to index all those components. So we're using, for each of our outputs, we're just grabbing those crossfaders, what we name them. So we name them crossfader 1, 2, 3, 4, so on and so forth without a space. Same thing with the gain. And we're just adding those to those tables to make them a little easier to find later in the code. We also have a table for storing the current source of all the outputs. And then we have some helper functions. So set feedback for the output. So that's going to set the toggle buttons and the knob later on. Then we have a go-to source. So this is a helper function for actually doing an actual routing. So it'll find that figure out which is the inactive channel. Is it the A or B, whichever one is not currently routed. Then it'll route that. Then it will do the appropriate fade. It will set the current source in this table, and then it'll set the feedback. This allows it to route back and forth very quickly, and it'll be able to crossfade even while it is currently crossfading. So you'll be able to switch inputs faster than it can fade, and it won't break the code at all. Then this code is what runs on startup to pretty much just set it all up. It's going to read the current sources when this starts up. It is going to set feedback for each output. It is going to set event handlers. So the select knob is going to just go to source of its current value and its output index. And then the input buttons will be their input index and output index, just using that go-to source helper. And then a little bit of extra logic that it makes sure that it goes back to true if it is the current source. So this way, if you select a source that is already selected, it stays high, just like a standard router does. Then we have our choices, and then if it is blank, we're going to use the first crossfade router in the that is embedded and just grab the type from that, since these strings will match. Then if the type is ever changed, for every output, we're going to change the crossfade type of every embedded crossfader to make sure they're all in sync. Same thing with the time. We're going to grab the value from the first crossfader on startup. Then if the time ever changes, then we're going to change all of them. And that's the entire plugin. For less than 1,000 lines of code that's generously spaced out, you have a very complex, small little plugin that solves a problem and saves you a lot of time on a job while giving your customer a great end user experience. Thank you very much.